Alright, today we're going to talk about identifying quadratic functions. So first, let's define what is a quadratic function. A quadratic function is any function that can be written in the form or written as y equals a times x squared plus b times x plus c, where we say then, along with that, a, b, and c are real numbers, and a cannot be 0. So earlier this year we talked about linear functions and how a function would be linear if there's a constant change in the x and a constant change in the y. We can do that here. However, there's going to be some constraints to this. So using a constant difference, I want to look first now at example 1 so we can see what that looks like. So here in example 1, we're going to identify if we have a quadratic function. And we're going to first look at a table, an XYT chart. And we're going to see if we have a constant change in x and y. So we're going to have the following x values: -4, -2, 0, 2, and 4. And then the y values we're going to have are 8, 2, 0, 2, and 8. So if we're wanting to check for a constant change of x, we're wanting to see when we go from one x term to the next, is it changing by the same amount? So when we go from -4 to -2, we are adding 2. When we go from -2 to 0, we are again adding 2. 0 to 2, we add 2. And 2 to 4, we add 2. So we've got a constant change in x here. That's good. We want to then look and see, do we have a constant change of y? So going from 8 to 2, we subtract 6. 2 to 0, we subtract 2. 0 to 2, we add 2. And then 2 to 8, we add 6. So that's not a constant change of y in what we call a first difference. If this was a linear function, the first difference would need to be constant. So we're going to do what's called finding a second difference. What that means is we're going to take the first difference and find the difference between each of those terms. So from -6 to -2, we had to add 4. From -2 to 2, we add 4, and from 2 to 6, we add 4. This blue part we call a second difference, and if that is constant, then we have a quadratic. So the question is this quadratic? Our answer is the table represents a quadratic function. So still in example 1, now we're going to look at B. We're going to be given the equation y equals -3x plus 20, and we're asked, is this quadratic? Well, seeing as there is no x squared term, we can say that this is not quadratic because there is no x squared term. The important part is that this is not quadratic. So then let's look at example 1c. We're going to have y plus 3x squared equals negative 4. We're going to solve this first for y. So to do that, we're going to subtract 3x squared on both sides. We're going to end up with y equals negative 3x squared minus 4. Well, we have an x squared term, so we can say that this is quadratic because we have a term with an x squared. Now, when we're talking about the graph of a quadratic, it has a special name. It's called a parabola. Parabolas are just graph of a quadratic function. So in example 2, what we're going to do is graph a quadratic. So we're going to take and graph y equals 2x squared, and to do that, we're going to make a table of values. Now, when I'm making a table of values, I always like to take two negative numbers, 0 and two positive numbers. So I like to take 0 and then just the two numbers that are smaller than that, negative 1 and negative 2, and the two numbers bigger than that, 1 and 2. If we plug those into our function, 2x squared, we're going to go 2 times negative 2 squared. So negative 2 times negative 2 is 4, and 4 times 2 is 8. So our first ordered pair is at negative 2, 8. Now let's find the second one. We're going to have 2 times negative 1 squared. Well, negative 1 times negative 1 is 1, and that times 2 is 2. We're going to continue filling in our table. We're going to go 2 times 0 squared. 0 squared is 0. 2 times 0 is 0. We're going to do this with 1 and 2 as well. 1 squared is 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. So now we're going to pull up a little graph and plot these points. So I've got my x-axis, my y-axis. I have negative 2, 8. So I plot my first point. I've got negative 1, 2, 0, 0, 1, 2, and 2, 8. Now I'm going to do my best to connect these dots. What a parabola is going to look like is going to be roughly shaped like a U. Now, I did not do mine very well, so let me redo this. Alright, so there's our graph of y equals 2x squared. So that was example 2a. Let's look at example 2b. We're going to do the same thing. We're going to have a different function, y equals negative 2x squared. So we're going to make our x, y, t chart. And I'm going to use the same x values, negative 2, negative 1, 0, 1, and 2. Now I'm going to plug those in. So if I have negative 2, times negative 2 squared. Well, we know negative 2 squared is 4, and 4 times negative 2 is negative 8. So we're going to keep going. Negative 2 times negative 1 squared. Negative 1 squared is 1. 1 times negative 2 is negative 2. We're going to have negative 2 times 0 squared. 0 squared is 0 times negative 2 is 0. Negative 2 times 1 squared. 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 times 2 squared. 2 squared is 4. 4 times negative 2 is negative 8. So now we're going to, we're going to graph that. We've got our x-axis and our y-axis. We have negative 2, negative 8. We've got negative 1, negative 2, 0, 0, 1, 2, and 2, negative 8. So we're going to connect these. And you might notice something. These two functions we just graphed, y equals negative 2x squared and y equals 2x squared, our y values, they were somewhat similar. The only difference is we took the opposites if we had a negative in front of the 2 in the function. And that actually brings a very interesting point up. What we can say is a parabola opens, meaning the direction that we draw the arrows opens upward when a is greater than 0, meaning when a is positive. And then the parabola opens downward when a is less than 0, meaning a is negative. And in our next example, example 3, we are going to determine if the parabola opens upward or downward. So I've got two equations we're going to look at. So first, equation A, I have y equals 4x squared. So this number in front of x, that's A. If that number is positive, like this 4, since A equals 4, that means the parabola opens upward. If that was a negative 4, then it would open downward. In example 3b, we're going to have 2x squared plus y equals 5. So we're going to solve this for y first. We're going to subtract 2x squared from each side. So we have y equals negative 2x squared plus 5. Since a is equal to negative 2 in this case, we say the parabola opens downward. Another way to think about it is if something's opening upward, it's U-shaped. If it opens downward, it's an upside down U. You could consider it kind of like an N or a mountain. Now we've got another new word, and that's a vertex. The vertex at a parabola is the highest or lowest point on a parabola. You can also think of it as the maximum or minimum. And then here we have a graphic for as just a description of minimum and maximum values. So we say if the parabola opens upward, the graph is going to have a minimum value, and if it opens downward, the graph has a maximum value. And you've got two pictures here that you can copy into your notes. So moving on to example 4, we are going to identify the vertex and determine if it is a maximum or minimum. So we got two parts. Part A we have this picture here. So to help us decide if A is a minimum or maximum, we just look. It's opening downward, so here we have a maximum. We can just say max for short. And then we give the ordered pair. So if we take that point and draw a line down, and then also a line over, we can know the x and the y values. So the ordered pair, the x value is 1, the y value is 5. So this graph has a maximum at 1, 5. Let's also look at example 1b, which again, we can do the same thing we just did. Since this opens upward, we're going to start by saying it has a minimum. We can just abbreviate that with the word min. If we draw a line up, we'll find the max, the x value, and then over will help us find the y value. So our ordered pair is going to be -2, -5. So we have a minimum at -2, -5. I would copy these pictures into your notebook. Now this next part should be a bit of a review. We're going to look at the domain and the range of these functions. And as a reminder, the domain represents all x values that are used or can be used to graph the function. The range is all the y values that are used to graph the function. So now in example 5, which for this video will be our last one, we are going to find the domain and range of the picture. And the picture looks just like this. So when we're asked to find the domain and range, with the quadratic, a normal quadratic, what we can say for the domain, it's going to be all real numbers. There's no numbers we can't use. With the range, it's not going to be all real numbers. With our linear functions we did earlier in the year, it was, but we here don't go any higher than the y value of 4. So our range is going to be all y values that are less than or equal to 4. So we've got our domain and our range. We're going to also look at characteristics of quadratic functions, but that's going to be in our next video.